other side right before we take the quiz. Okay, we'll go through it quickly though, because you know, we did a bunch of problems yesterday and now we're doing one today, so we won't have to spend much time on it. But let's start on the side that says quiz 2.6 practice. In that order, quiz 2.6 practice. All right, so here's the problem you're going to draw a picture of. So let's see what you remember in terms of vertical asymptotes, horizontal asymptotes, holes, x-intercepts, and y-intercepts. All right, so what do you know?
Yes, ma'am.
What do you know? Logan?
I know the horizontal asymptote is 2/1.
The horizontal asymptote is y equals 2. You are exactly right. 2x over 1x. That's right. So on my horizontal asymptote's going to look like that. Perfect. All right. Who knows something else?
Vertical is -1.
X equals -1. Because where do vertical asymptotes come from? Denominator equals 0. So clearly, if you put in a -1, you're going to get a 0. Okay, so I'm missing Maddie and Hunter and Addie and Pat. Is that it?
Oh, was Pat on here? That's why it's quiet.
All right, what else?
There are no holes.
There are no holes. Because the only way to get a hole is to be able to factor and cancel. And we can't, so we don't have any. All right, what else? You feel all right?
The x-intercept.
We need our intercepts and their points, right? And to find the intercepts, what do?
Plug in x.
Plug in zeros, right? One at a time. So if you put in a 0 for x, put in a 0 for x, what is your y value? If you put in a 0, it'd be 4 over 1 or 4. So that's a y value, so it's a y-intercept. 0, 4. Now, remember, this is written as a function, but remember, this is the same as y, right? This is y. So if I put 0 in for y, then I have this equation. I'm putting 0 in for y. And what happens to the denominator? Disappears, because you're timesing it by 0. So you're left solving that equation. And if you solve that, subtract 4, divide by 2, you get -2 is your x value. It would literally say x equals -2. That's your x-intercept. That's your x value. It's -2. Based on that, you should be able to draw the picture, because you remember that in a rational function, you always have the reciprocal function idea. So you've got these things moved around, maybe flipped around, but those are the shapes. So given that you have a dot right here, and here are your asymptotes, it's pretty obvious, or should be, I hope, that it looks like that. Now, we're not going to be curving it back. We're not going to be curving it down. It's going to follow its asymptote straight off the page. Then what happens over here? Well, see that dot right there? That tells you that it is up here. And isn't that the reciprocal function, just with the origin in a different spot? And that's how they always look. Now, you'll say, Ms. Ford, they don't always look that way, because yesterday we had some strange things. When did the strange things happen?
There's a hole.
No, when we had middle section because we had 2 vertical asymptotes. If you only have 1 vertical asymptote, that's what your picture's going to look like. There might be a hole in it somewhere, but that isn't going to change the shape of it. If there's only 1 vertical asymptote, that's what it's going to look like. That shape. Okay? All right. Hang on to that paper. We'll do the other side. Next time I see you, which Lord only knows when that will be.
Next Tuesday.
A week from today.
Yeah.
Lord, I'm gonna miss you.
I'm gonna miss you too. I think we should have school someday.
No.
Sunday.
Well,
I'm good.
someday we should have school. Like, I don't know, Friday.
Not a chance.
All right, here we go. Here we go. What is this? This is the next page of notes. It's called 2.7. Notice the directions have changed. We are no longer sketching. We are now solving. So we won't draw a picture. We'll end up with something that says x equals 7. We're solving. Now, I heard somebody has already looked at this problem and said, why don't we just multiply by 4? And why would we do that? What is the value of multiplying by 4?
Cancel your denominators.
It will get rid of the denominators so that we have no more fractions. Now we have x minus 1, x plus 4 equals 3.
Combine like this.
We have an equation that's solvable by just about everybody. I mean, even little kids can solve something like this. We have 2 x's plus 3 equals 3. If I collect like terms over here,
2x equals 0.
so 2x equals 0 and x equals 0. That was pretty darn easy. You are exactly right.
Okay, that's it?
That's it. Now, when I see this one,
Ooh, I got
I am going to use exactly the same logic that I used a minute ago.
Multiply by
You told me I should multiply by 4 because that would cancel the denominators. What would I multiply here
X.
to cancel the denominators? X. So I am going to multiply everything by x. Now, when I do that, it's going to cancel those out.
X squared plus 2x minus
But it
15.
doesn't cancel anything else. So I am left with x squared plus 2x equals 15.
X plus 5x
Because
minus 3.
that x canceled, but these didn't because there weren't any denominators. Do you see that? Now, what do I do with that? Exactly. I move the 15 over, and then like she said, I have a quadratic now, and I can do whatever I want with it. I can try to factor it. Does it factor?
Yes.
I think so. If it didn't factor, or if I didn't want to factor it, I could use the quadratic formula. You could even complete the square on this if you wanted to. Whatever flips your switch. I think it factors, so I'm going to go ahead and do that. But again, you don't have to. You've got other options. So what are my answers? Boys, men.
Negative 5 and 3.
Negative 5 and 3. So far, so good, everyone?
Yes, ma'am.
These don't seem too bad at all. Let's see about the next one. All right, what do you think about this one? Would you multiply everything by x again? Yes, because what is kind of our go-to procedure? Multiply to clear the denominators. So the only denominator I have is right there, so I'm going to multiply to clear him. Now, the reason you did it is so these would cancel. That is not going to be a 12x. That's going to be a plain 12. This is going to be x squared. And that's going to be 7x. But this one canceled. All right, what do we do?
Subtract 7 over.
Subtract the 7x over, and I'm actually going to put it in the middle if that's okay, because that way it'll be in the right order.
X minus 4, x minus 3.
Am I same place I was a second ago, right? So this one factors, but again, if it doesn't or you don't want to do it, that's fine. Use your quadratic formula. This one would be a little harder to complete the square because you'd have a fraction, but if you want to, you can go ahead. X equals 4 or 3. Wow. What a great way to end the week. So easy.
Oh, this is hard. Plus 4x.
Could you multiply?
Cross
Could you multiply x squared plus 4x? That would be harder.
That is what we're actually going to end up multiplying by, but we're going to do it in its factored form. So the first thing I'm going to do is factor any denominator that factors. So that one doesn't factor, but this one factors into x and x plus 4.
Yep.
And by the way, if it helps you, this is over 1, right?
Yeah.
So it also has a denominator, it just happens to be 1. Which you can write or not write, it doesn't matter. Now, our job is to take our purple marker and to multiply by whatever we need to multiply by that will get rid, thinking ahead, get rid of both denominators. Now notice I am putting 2 parentheses there because I would need to multiply by an x and an x plus 4 in order to get rid of all of this, right? Now you can say, Miss Ford, you only need an x plus 4 here. You're right, but I have to get rid of all the denominators. So I gotta multiply by the most. I'm multiplying by x and x plus 4. So the whole common denominator is what I need to multiply by. Now when I do that, and some of you are going to be lazy, and you're not going to write this down, but I always write it down. Because when I do that, I can see exactly what cancels. Nothing cancels here. What cancels here?
The x plus 4.
The x plus 4 is gone. What cancels here?
All of them.
All of it. So now I'm going to write down what I have left, which is 2x, x plus 4, all that's left, minus what? 3x equals what? 12. That is all that's left. Now what do you think we ought to do with that? Distribute. So 2x squared plus 8x minus 3x equals 12? What do you think? Combine like terms? So what? 2x squared plus 5x. Can I go ahead and bring the 12 over? It might factor, but it's kind of, oh, it does? You've already figured it out?
Yep.
So if you can figure out the factoring, it's okay to do that. But again, if you don't want to factor, don't know how to factor, can't stand to factor, you can always use the quadratic formula, right? Alright, let's see, how does this factor? 2x
minus 3
plus 4 minus 3. Is that right?
Yep.
So what are the answers? That's not it, we're not done. The answers are x equals. So what does x equal? X either equals, oh, watch this
Negative
one.
3 halves.
No, you
Oh,
might
sorry.
want to write it
X
out.
equals 3 halves.
Won't it be 3 halves?
Yeah.
Don't be afraid to write it out. You don't want to do all that work and then screw up at the very end. Or negative 4. Beep, 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 beep. My extraneous root antenna are up. Yes. You need to develop extraneous root antenna. They are up because what happens if I put this answer into the original problem? I get a 0 in the denominator. That is not allowed.
Oh my God.
So this is an extraneous root, and the only answer to the problem is right there. In the original problem, it is clear to me that x cannot be negative 4. It is also clear that x couldn't be 0, but I don't need to worry about that because I didn't get that as one of my answers. Whatever answers you get, you have to be able to plug them back in. I mean, that's what answers are. They're numbers that work in the equation. Negative 4 will not work in that equation. Right? Got to develop those antennae. All right, let's try the next one. Am I ready for number 5? Okay. Now, tell me what you think I should do first.
Oh, foil.
Factor.
Foil.
Absolutely. Reverse foil. Unfoil. I need to factor that. Please make a note in your notes that you should always factor your denominators. If your denominators factor them. Always, always factor your denominators. Now I have my blue marker and I'm going to multiply by something that is going to cancel out every single piece of the denominator. So what am I going to need to multiply by? X plus 4 and x minus 1. X plus 4 and x minus 1. Please don't be lazy. It takes 2 seconds to write that down, and if you write it down, then it becomes clear what is staying and what is going. In the first fraction, the x minus 4s are going, right?
Yeah.
So we're left with a 4x and an x minus 1. That's what we have left for the first fraction. Plus, now these cancel, and I'm left with 3x plus 4. Are you watching?
Yes.
What happens here?
Everything.
It's all gone except the 15, so it's equals 15. Everything cancels. Now I see a bunch of you writing. What are you doing? Distributing. So 4x squared minus 4x plus 3x plus 12 equals 15. Yeah, the 15 is going to come over. I also can combine that, can't I? What do you think about that? Does that seem about right?
Yes.
Okay, so we're right back to where we've been like 3 or 4 times already today. We either need to figure out how to factor that, or we use.
I found it.
You found it?
Yeah, I know that.
All right. When we're in a group, we can factor these. Remember, kids, when you're on your own, you do not have to factor. You can always,
Plus 3 and minus 1.
you can do the problem with the quadratic formula. Okay, if it's a quadratic.
Can we practice one next?
Yeah, the next one comes out that way, we'll practice it. Okay? Now, what are my answers then?
You gotta.
X equals -3/4.
Negative 3/4. Now, I don't know if Sam knows that or if he wrote it down.
Zero down.
Do not be afraid to write it down and solve it, because that way you know you'll get the right answer. If you're just guessing numbers, probably you're going to miss it.
X equals 1 minus 1 is 0.
Guess what? Here they come. This is an extraneous fruit, because what happens when I plug 1 in here? I get 0, and I can't do that. -4 would also be extraneous, but I don't need to worry about it because it didn't come out as an answer. I only have to worry about it if I get them as answers. No, I don't even want to say that.
I'm not.
Okay. What did I tell you was step 1? Have we forgotten already?
All the.
You gotta factor the denominator. Please, factor your denominators. I'll tell you, the problems are doable without doing that, but they get bigger and uglier. So it's always a good idea to factor your denominators. I keep putting equals there as a plus. So the only denominator that factors is that one, and all I can do is pull out a GCF, right? Okay. Now we're ready to multiply, right? And what do we need to multiply by? Whatever it takes to get rid of every denominator. So it's clearly going to take an X, and it's going to take an X plus 1. So everybody gets an X and an X plus 1. Everybody, including the 0. Now, the good news is, what's 0 times anything?
0.
0. So that's going to stay 0. I don't need to worry about that. And then over here, we're going to get some canceling. So that's going to cancel out. And it's going to leave me with X minus 3 and X plus 1. You still with me?
Yes.
So now I got a minus. Sometimes I get so much written up here, we lose it. There's a minus right there. So it's minus 3x. And then plus 3. Okay, what are we going to do with that? Going to do some four-linear distributing right here, right? So we're going to get x squared
Plus X.
plus x
Minus 3X. Minus 3.
minus 3x plus 3.
Oh, that's a bunch of.
Right? Don't forget about this part.
Yeah.
Okay, so let's go up by terms. We have x squared. How many x's do we have? I have 1, minus 3, and minus 3. Minus 5x equals 0?
No.
The 3's cancel? Does that factor? Yes, it does. It has a GCF. So x and x plus 5, or minus 5, I'm sorry. X and x minus 5. So x equals 0 or x equals 5.
Infinite many.
What happens if I put 0 in? It won't work. That's extraneous. The only answer to the problem is 5. One more, guys. All right, so you're getting good at this. Pretend you're sitting there all by yourself and you have to do this problem. What would you do first? Is he awake? Brendan?
Jeez, they're not as enthusiastic about math.
I know.
I know, right?
I know. We have a word for that, but I'm not going to say it on video. Here we go.
What is it?
Here we go. What's the first thing I need to do? Factor.
This video will end the long time.
Anthony, you keep it going.
Just stop it. Okay, so the denominator is factored. All right. Now I'm going to multiply by something. That's always how I start. Once I get factored, I start by multiplying. What am I going to be multiplying by? Two things. X plus 2 and x minus 1. Everybody gets multiplied by x plus 2 and x minus 1. Once I do that, what do I notice? X plus 2 is going to cancel in the first term and leave me with 3x, x minus 1. Are you doing this on your own? Okay. And then we'll do it here too. So what am I left with plus in my next term? 2x plus 2. Now I got my equal sign. And what's it going to equal? 5. Just 5. Because everything else canceled out. So do you know what to do now?
3x squared.
Distribute. So yep, 3x squared minus 3x.
Plus 2x plus 4 equals 5. We got to subtract 5 over.
And combine here. So we'll have 3x squared
Minus x.
minus x minus 1.
I used quadratic.
Now Shiloh asked that we do the quadratic formula to practice it. And actually, I think we have to in this
We
one
have to because there's no factor.
because it doesn't factor. So we're going to get some good practice here. So x equals, here's my equation, negative b plus or minus the square root of b squared minus 4ac all over 2a.
1 plus or minus.
Look at that, wait, look at that and make sure you understand where all those numbers came from. Everybody good?
Yes.
Garrett, what's on your iPad, honey? Is it math? Okay, well, let's put it down. It's not math. There is nothing more riveting at this moment than our rational equations. Everybody okay with what's underneath? So 1 plus or minus the square root of 13.
That's the answer.
And there they are. Those are the solutions to the equation. Now, you might be thinking, well, Mrs. Ford, should my radar be up? No. The only numbers that are going to cause my radar to go up would be -2 and +1. I didn't get those, so these are my answers. And it is perfectly okay to have radical answers. Okay? All right. Let's stop.
Still 20 minutes left.
Now, this isn't a big stretch. Look at the directions for this next section. Solve the following. That's what we've been doing. Now, the difference is I see an inequality in there. So,
Please tell me there's no shading.
there is shading. Brendan said, please tell me there's no shading. Anytime you have that symbol, there's going to be shading. That's going to happen every time you have a less than or a greater than. Now, but we actually did do them earlier in the year. This is going to come back to you. Here's what I want you to do. I want you to draw a number line. And on the number line, you're going to put 2 dots. Yep. Take a wild guess.
3 and -2.
You're going to have a dot at 3 and a dot at -2. Now, for this to work, you've got to have the dots in the order they come on the number line. So if you were putting in all the numbers, you'd have -2 before 3, right? So make sure they're in the right order. Then we shade. Does anybody remember our shading rule? If it's less than, we shade in between the dots.
Yes.
If it's greater than, we shade outside the dots. Boys and girls, this is nothing different than you've already done this year. If you have 2 dots on the number line, you shade either between them or out of them. Okay? In this case, we're going to shade between them because it's a less than problem. And then I'm giving you complete and total control over how you write your answer. You can either write it as an interval, which is the way you will write it in your calculus class, or you can write it like you did last year in algebra as a set. Either one is perfectly fine. No other answer is okay. You're either going to write it this way or this way. Wow, that is so easy. Now, let's look at this one. The dots are going to go at exactly the same places, aren't they, kids?
Yes.
But that squared messes everything up. Yep. As soon as you put a squared or cubed or anything other than a plain factor, it messes everything up. Okay? So here's what we have to do. You don't like it, I don't like it, no one likes it, but it's what you have to do. If you have any kind of squared factors, I want you to think of any number in the whole wide world
7.
that's over here.
Negative 6.
Negative 3.
I heard -6. Someone said -6. Would you agree this is over here?
Yes.
I'm not gonna use 60, it's too big of a number, but I'm good with this, all right? So I'm gonna come up with my equation and I'm gonna put in -6. So if I put in -6, I would get -4. And if I put in -6, I would actually get -9, but squared would be 81. When I multiply those two together, I get -324. Now, the 324 part isn't even important. What's important is it's negative. This answer I get is supposed to be less than 0. Is -324 less than 0?
Yes.
Yes. So when it's a yes, you shade it. So I put in -6 and I got a negative answer, which is what I want.
So, all you have to do is pick a number smaller than.
But I'm not done, because now I have to pick a number and do the same thing in here. So 4 is not in here, so I'm not picking 4. 1 is fine, so I'll pick 1. Now, when I put 1 in, I get 3 times -2 squared, which is 4, is 12 less than 0? No. So don't shade that part. So now I can pick 4 or something else. 4 plus 2 is 6. 4 minus 3 is 1, squared is 1. I get 6. Is it less than 0? No. So I don't shade that either. So the answer to the problem ends up being, no, the number's less than -2. That was a yes, remember? And when it's a yes, you shade it and it becomes part of your answer. Okay? Now, you can also write that as an interval. Those of you that like intervals, it would be written like this if you wanted to write it that way. Now, listen to me. What made this problem so easy?
There was no square.
There was no square. So when there's no squares, it's a lot easier. Oh Lord, look at the next one.
Oh no.
You guys are enjoying this so much, we might just have to stay and finish up.
Sorry.
All right. So here's, the dots are in the same spot. That hasn't changed. The dots are in exactly the same spot. And now I'm going to pick my numbers again.
7.
And I can pick any number I want. Now, I like to keep them as close to these as possible because that keeps these smaller. You could pick 100, but that's going to be a huge number, so I'm not going to do it. I'm just going to pick 4. So if I put in 4, I get 4 plus 2 squared. 36 times 4 minus 3 squared. So that's 36. Is 36 less than 0? No. So that one I don't shade. How about using 0? Let's use 0. That would be an option, right?
2.
So I'm using 0. So 0 plus 2 is 4, or squared is 4. 0 minus 3 squared is 9. Is 4 times 9 less than 0?
Oh.
All right, I don't shade there either. All right, -3. -3 plus 2 is negative 1, squared is 1.
1.
Negative 3 minus 3 is negative 6, squared is 36.
No.
No solution.
No solution.
That's right.
No, Jones. No solution.
Wait, so what is it, like 3?
What?
Why did you do it 3 times?
Because there's 3 sections on the number line. You have to check every section. If there were more dots, I'd have more sections. All right, just a few more.
10 minutes left.
I know. We can get a lot done in 10 minutes. Alrighty. This looks different. What do you think we might do to start?
Factor?
Factor. What a great idea. Exactly. These, by the way, when I give you these, they will always factor. I won't make you have weird radical stuff on these. These will all factor. So this factors into x plus 4 minus 1.
Oh, that wasn't too hard.
Nope. So then we'll go straight to our number line and we'll put a couple dots on it. Only have 2 parentheses, so I'm only going to have 2 dots. And the dots will be at negative 4 and positive 1. Now wait, does my problem have any squares? No. So if you want to use the shortcut, you can. Now you can also check, just like we did before, that will always work. But because there's no squares, if you see the greater than, you know you're shaded out. So you're shaded out this way and out this way. If you can't remember that rule, don't want to remember that rule, or are afraid you'll mess that rule up, then pick a number in each section, which is what you have to do if you have a square. So my answer, I'll either write it this way, it's a 2-part answer, or if you like intervals, I think this is harder this time, but if you want to use intervals, it would look like that. Now, I bet you can do this one all by yourself.
I can't.
Let's give it a whirl.
Take the train over
Good,
there.
Valerie? Nope.
I'm not smart either.
I think we're all smart.
I'm Christian.
Let's go.
I can't do it.
Come on, Jody, let's get her factored. We're gonna get her factored.
Circle shade that way.
Hopefully you got it factored into -4, -3.
Yes.
So hopefully you have 2 dots on your number line, 1 at 3 and 1 at 4. And hopefully you colored them in. We haven't had one colored in yet. Why? Somebody said why?
What line are there? Or?
Because it's an or equal to problem and we always color the dots on an or equal to, right? Now, are either of your factors squared?
No.
So if you want to shortcut it, you can. As long as nothing's squared, the shortcut will always work. If it's greater than, it's going out. So x is less than or equal to 3 or greater than or equal to 4. Or negative infinity to 3 bracket this time. Or infinity.
Why isn't it shaded all to the right?
What?
Why isn't it shaded all to the right? Like, you know, I'll be
It is shaded all to the right.
like, so,
Because if you put in the number 3.5, it won't work. 3.5 would give you a negative 0.5 and a positive 0.5. Multiplying those does not give you a positive number. You're trying to use 1 dot rules on a 2 dot problem and you can't. All right, one more.
Hi, Gabriella.
Yeah, if you're a swimmer, you can go. I mean, if you're a swimmer on the list, you can go. I know she does. All right, guys, this is going to be a challenge. Wait, are you on the swimming list?
Yes.
Yeah, I'm in green team.
I saw her at the meeting.
Yeah, I was in yesterday.
Okay.
I was at practice with her last
It's not if you're on the swim team, it's if you're on the list to have early dismissal.
You not on the list. Yeah, get back in there. Just one problem.
All right.
Cute,
here we go.
chill, bro. Don't push that pain.
What? Guys. Cute. Focus. Look at this, guys. Oh my gosh.
Please talk about grouping.
It doesn't group.
Oh, well.
No solution.
Let's just put no slides in.
Yeah,
What do we
really.
do if they don't group?
Sleep.
Synthetic division. And what numbers do I guess as I start synthetically dividing?
1, 2.
Plus or minus 1, 2, 3, and 6
Yeah,
over 1.
it's 2. The answer's always 2.
It's always 2, so we'll try 2.
it's 2. Is it 2?
Oh, I don't think 2 works this time.
Darn.
3. 3. I didn't know.
Oh, she got that.
Somebody said 3. Shut up,
Stop
Sam.
saying.
We already tried.
Yeah, shut up. They even saying.
All right, 3 did. 3 worked.
Is that it? I hope so.
Where do I go from here?
You, remainder 4 and 2.
I take a look at this right here, which is x squared plus x minus 2. Yeah, I'll come back to that in a minute, but I gotta finish factoring this guy.
Oh, you know, it's negative 1, 1.
He factors into x plus 2 minus 1.
Duh. Stupid.
Now, kids, that's what you just took a test over. Now we're going to take it one step further because we are going to graph it as an inequality. But remember how I kept warning you about not losing this guy? You can't lose him now either. He is x minus 3 and he has to be part of your answer. Okay? So the one I guessed correctly comes out here. And if 3 is the number, then x minus 3 is the factor. And then here are the 2 factors that I just got when I factored. So now my number line has 3 dots. And the dots are at negative 2, positive 1, and positive 3.
Yeah.
Now there's too many dots. I can't do my out-in thing. But the good news is, I only have to check one number. I don't know if you remember this or not. But if nothing is squared, they're going to alternate. So once I figure out what one of them is, I can alternate to find the rest. So pick whatever number you want that's not up there already.
Negative 3.
Negative 3. If I put negative 3 in, I get negative 6 times negative 1 times negative 4.
As we come to the end of the day, let us
Will that be negative or positive?
negative myself,
Shade.
take care of everything. In the name of the Father, the Son, and the Holy Spirit. Hail Mary, full of grace, the Lord is with thee. Blessed are you among women, and blessed is the fruit of thy womb, Jesus. Holy Mary, Mother of God, pray for us sinners, now and at the hour of our death. In the name of the Father,
Sit down.
and of the Holy Spirit. Amen.
Sit down. We got one more thing to finish.
Class has ended. Go in peace.
All right. So this section worked. Alternate your shading. So if you shaded here, don't shade here. You shade here, don't shade there. And that's your answer. All right. God bless you.